Welcome to one more Flip Classroom math video. 3 tips before you start. First, you could slow down or speed up the playback if that helps you watch the video at your own pace. Second, you could pause the video anytime to jot down notes. Third, you could turn on the captions and watch my words go by on the bottom of your screen. Today's lesson is about Jim's Law. And Jim Richards is one of my mentors from years back. He's a former faculty at my school, and his poster or his portrait hangs in the science lab if you ever want to take a look at that. And Jim helped me conceptualize the project that we're currently working on, where we're going to measure the elevation of one of the red rock monoliths that surrounds our school. And we can't measure this directly. There's no way to do that because there's a lot of earth in the way. You can't do that. So we need to use trigonometry to find the elevation of the top of the summit of Napoleon. So Jim has done this project before and he shared it with me, so I did it with my students many years ago, and we're bringing it back this year. So Jim's Law. I decided to call this formula Jim's Law just in honor of Jim for having come up with it and sharing it with me and hence with you guys. So let's take a look at this diagram. I've got basically 3 triangles here. There's the big triangle that's outside, then we have a little right triangle here, and then just a little obtuse triangle there. Okay, so there's 3 triangles, and I've marked 4 quantities on them. I've marked this distance, this angle, theta, this angle, alpha, and then this h, height. And we'll talk about how that relates to our word problem, to our project problem in a minute, but right now let's just take a look at the pure geometry of this. So here's what we're going to do. We're going to find the height if theta, alpha, and d are known. And if you look at that, you can see that we do have a right triangle in here, and we can do SOHCAHTOA trigonometry on a right triangle. But if you stare at that picture long enough, you realize that you don't have enough information. If I gave you alpha, that's great, but you don't have any lengths in that triangle. So you can't use SOHCAHTOA. In fact, you can't use the sine rule or the cosine rule because you do need at least one length to use those rules. And the only length we have is this one out here in our obtuse triangle. Now, don't fret. That information is enough to find h. So what we're going to do right now is we're going to derive a formula that will give us h. Okay, so our first step, we are going to need to come up with something about this angle. This beta up here, I've labeled it with the Greek letter beta, and knowing that angle is going to be helpful for us. So here's the thing. Beta is in this rectangle, this obtuse rectangle. So all we need to do to find beta is subtract theta and whatever this is from 180, and we'll know what beta is. So beta is going to equal 180 minus theta. We have to subtract this angle. Now pause the video and think about your geometry for a minute. How might we express this angle here, the one that doesn't have a letter in it? All right, if you came up with 180 minus alpha, you're right, because if you go from here all the way over to there, that's 180. So 180 minus alpha is going to be this angle here. So what we're going to do is we're going to subtract 180 minus alpha. And this is going to give us beta. So let's simplify. I'm going to bring down, now minus 180 minus alpha is plus alpha. So then we're going to get, I have 2 180s, they cancel. That's going to leave us with a negative theta and a positive alpha. So I'm going to write that this way, alpha minus theta. So that is what beta is. It's just alpha minus theta. And this is nice because we are given alpha and theta. So we can find angle beta. Okay, I added an L to our diagram. We're going to need to show this side in our work. It won't be in our final formula, but we're going to need to use it in our work to derive that formula. Okay, our next step is going to require that we momentarily use L for this side in this right triangle. So we're going to deal with this right triangle, and we can use the sine rule to write an equation that relates LH and alpha. Pause the video for a second and see if you can do that. Okay, let's see what you did. Step 2. So in that triangle, I'm going to have h over sine alpha, because that's side length over sine of opposite angle. And then I can write L over sine of that angle. So I write L over, and what is that angle? 90. Now this is nice, because what's sine 90? Now if you're familiar with the unit circle and stuff, you know right away that sine 90 is 1. You can use your calculator, that will confirm that for you. So this is going to give us h over sine alpha equals L. It's just L right there. Okay, we're just going to note this. We're going to do a substitution with it in another step. So just know L is h sine alpha. Okay, third step. Okay, our next step is going to be to use a sine rule to write a proportion for this triangle, for our obtuse triangle. So what we're going to get here is we're going to get L over sine theta equals D over sine beta. But we know what sine beta is, and we know what beta is. Beta is alpha minus theta, so this is going to be D over sine alpha minus theta. And that's just what it looks like. If this angle was 62 degrees and that angle was 5, you'd take the sine of 62 minus 5, or 57, and that's what that would be. So now I have this other relation. I know that L over sine theta is the same as D over sine alpha minus theta. Now pause the video and see how you might manipulate that. Okay, what we're going to do is we're going to solve for L here. We're going to move it around just a little bit. So L is going to equal D times sine theta over sine alpha minus theta. Okay? Now, I know you're probably going, what is he doing? Why is he taking all these steps? Where is he going? This is the nature of a proof, okay? So to do this, like if I had originated this formula and proved it, it would have taken me a lot longer. I would have gone down some dead ends. I would have gotten lost and confused and backed up and then figured it out. But ultimately, these steps are steps that will derive a formula for H in terms of theta, alpha, and D. Okay, so let's go on to our next step. Okay, so here's an instruction. I'm going to ask you to pause the video and see if you can do this. What you're going to do is you're going to take what you found in step 2 and substitute that into step 4 and then rearrange or solve for H. So pause the video and give that a try. Okay, so from step 2, we figured out that L had to be H over sine alpha. And then from step 4, we also figured out that H had to be D times sine theta over sine of alpha minus theta. So since these two quantities equal L, they equal each other. So now what we can do is just get rid of the L, and we've done our substitution. We put H over sine alpha in for L from step 3, and now we just need to solve for H. We've got H over sine alpha, so I'm going to multiply both sides by sine alpha, and I'm going to have H equals D times sine theta times sine alpha all over sine theta minus alpha. And so now I've got what I needed. I've got what this problem is asking for. I'm going to cook up an example and we'll work a problem. Okay, here we go. I've given you some numbers now. D is 16.5, let's say meters, 16.5 meters. Theta is 38 and alpha is 44, okay? So here are the 3 variables that let you find H. Let's do a plug-in and see what we get. Remember, if this is 16.5, then our H shouldn't be 500 and it shouldn't be like 2. It should be something that makes sense with D being 16.5. So let's do our plug-in. H is going to be 16.5 times sine of theta, 38, times the sine of 44, all over the sine of 44 minus 38. So that's the plug-in step. Make sure you get that right. You won't get the right answer if you don't do this part right. So now I'm going to pull out my calculator and do a calculation. You pause the video and do the same thing. Okay, when I calculated it, I get h equals 67.5 meters. Okay, I'm going to leave you with a problem, and I'm not going to solve it. I want you to figure this out. Jim's law will help us do this problem. So what we're going to do is we're going to get down on the basketball court and we're going to make our measurements. And we're going to measure, we're going to ultimately find out what the elevation of Napoleon is. So what I want you to do now is pause the video and make a sketch. Use your notes from Jim's law and see if you can draw the right lines on this diagram so that you have your alpha that you can measure, that's in your power to measure. You have your theta that's also in your power to measure, and you have your little d. So however you draw those lines, they need to be in such a way that you have access to those two angles and that one distance. So go ahead and pause the video and do all that, or let the video finish and do all that, and we will talk about this in our next class. Now that you've watched the video, take a moment to jot down any remaining questions so you can bring them to our next class. You can also watch the video again if you need to deepen your understanding. If you enjoyed the experience, please click like or subscribe.